Good morning and welcome to Math 8 and doing 3-6 lesson for sketching functions from verbal descriptions. If you have me for class, this would be the last page of our note packet today, and not the back side but the front side of that page. And we are going to do exactly as it says. We're going to sketch functions based upon what the description tells us. So we're going to start with example 1, where it says a scuba diver starts to dive with a full tank of oxygen. While diving, she breathes at a constant rate. She checks the gauge after 22 minutes. Sketch a graph of this function. Be sure to label the independent and dependent variables. Okay, so when you are sketching a graph of a function, first thing you need is an axis. So this one is, there's not going to be negative levels of oxygen and there's not going to be negative time. So we only need our positive parts of our axis. Now we need to decide what are our independent and dependent variables. So when we talk about time, and in this case it says minutes, which is why we know we're talking about time, most of those are going to be our independent variable. If you've got time in there, that's going to be our independent. An independent variable always goes across the x-axis. So we're going to label our x-axis with time. All right, and so we know, for example, we need to get all the way to 22 minutes here on time. And she's going to check her oxygen levels at 22 minutes. That doesn't necessarily mean that she's going to run out of oxygen then, but she's going to check it. So we'll make sure that we label, let's say, 22 minutes here. And this over here would be 0. And then this side, our dependent variable, we want to make sure we label as well. So what are we measuring when we're doing this? We're measuring time, and we're also measuring how much oxygen she has in her tank, okay? So we want to make this our oxygen level. Okay, and so the gauge for oxygen usually is in PSI. If you didn't have that or know that, you could at least write oxygen level. So when she starts, it tells you she starts with a full tank of oxygen. It doesn't tell us how much, but we know that it's going to be somewhere high. So we're going to start her up here, right? And this constant rate means that she is going to lose the oxygen out of her tank, and it's not going to be jagged. It's going to be this nice smooth line. So the oxygen levels are going to go down at a constant rate. So we want to make sure, and eventually they will run out. That tank isn't forever. And so this is what that graph looks like. She's going to check it at 22 minutes, and we don't really have enough information to know whether or not she is, or how much oxygen she has left. But if she's checking it at 22 minutes and still breathing, we know that probably she has more. So this would be a graph of our description here. Oh yeah, this is also our dependent variable. Let's label that. And so this is how our sketch would look. And we can't really include any more information because it doesn't give us any numbers to go with it. It doesn't give us the actual rate. It doesn't give us how much oxygen was actually in there. It doesn't give us when it ran out. So we can only label our independent, dependent variables, label our 0, and make some assumptions. Okay, we're going to save the try it. You can do that on your own. But we are going to continue with our next example for the sake of the video. So that's on the very last page of our note packet. All right, and so here's our next example. And it's the same idea. I know on your copy it's a little hard to see, so I darkened mine in. It says, Danica sketched the relationship between height and time for one of her parasailing flights. Describe the behavior of the function in each interval based on her sketch. So we're going to make the sketch for her, actually. and because it's not, you can't really see it. So from mine, I will show you what the sketch looks like. So this is what it started with in our book, which we don't have with us today. So we're going to go ahead and sketch this out. So the height and time for Danica looks like this. It's going to go up like this, and there you can kind of see a dot there, and then we're going to go over like this for a little bit, and then we're going to go back down kind of at a faster rate, excuse me. Okay, so what we want to do is describe the behavior of the function, okay? Notice I underlined height and time because height is our dependent variable here, and our independent variable, again, we're talking about time. So if she's parasailing, that means that in our first interval right here, she is being pulled up into the air. So a parasailing is like, usually you're being pulled behind a boat, right? So here's our boat, and they pull you up. Here's Danica right here. She's got her little harness on, and they usually have a balloon type thing that holds you up in the air while the boat pulls you in the water, okay? So you get pulled up. So this first interval, interval 1, Danica is being pulled into the air. Danica is being pulled into the air. All right, and then, so that's our first interval. See? Boop, 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 boop. That's interval 1. Okay, our second interval is right here, and it's flat. So interval 2, what's happening there? Okay, what do we think? So if she's being pulled up into the air in the first one, interval 2 is when she's parasailing. She's kind of sitting there at a constant height. So she's staying up in the air at that same height for a little while. Okay, so Danica is parasailing at a constant height. And that word constant is very important there because it is a flat line. Okay, and then our last interval, interval 3, there's only 3 of them going up and down here. It's a little steeper, so she's coming back down kind of at a fast rate, and maybe I should have done that a little less steep. But what's happening in this last interval is she is dropping back into, they can't just like get her back into the boat, they got to drop her into the water. So Danica is dropping back into the water. And that would be our description. And so that's what it's asking us, okay? So it said that we needed to describe the behavior. So you describe the behavior based upon the intervals shown. And we had to draw our intervals in, of course, because on our copies, those gray lines just don't show up. Okay, last example then is to draw your own and label your own. So I started this last example, but I will push it up here. So this last example says, Jose is practicing javelin throws. So if you don't know what a javelin is, it looks like a big, kind of like a spike they can throw them in the Olympics, okay? And so if he's going to throw this javelin, it says, what relationship between height and time? What is the relationship between height and time? And so, again, we've got that time. That's going to be our independent variable. And so that means that we're labeling our height, the other variable, as our dependent variable. It says, what would the graph look like? So let's start with what the graph would look like. So if he's going to throw a javelin, so if he's standing here, he's going to throw that javelin, which again looks kind of like a spike, all right? Big long one like this with a pointed end. He's going to throw it. So what's going to happen here is we're not going to start down at 0 for our height. 0 is going to be our time, but our height's not going to be 0. It's going to be however tall Jose is or wherever his arm reaches. So it's going to start up here somewhere. And when he throws it, it's heavy, so it'll be up in the air for a little bit, but then it's going to quickly fall back down to the ground, and it will probably spike and stick right in there. Okay? And so this is what the graph would look like. Let's pretend that's the javelin. So that's what the graph looks like. What would be the relationship? So the relationship, we would describe it like this. As the time increases, right? So we've got the time is always increases. The height, what does it do? The height increases for a while, right? So this really means that we've got 2 intervals here. So the height increases in the first interval. Because we know that it's going to drop, we can see that it's going to drop, there's another interval. So we have to talk about the second interval. And so in the second interval, in interval 2, as time increases, what's happening there? The javelin's dropping, right? The height then decreases. And that's how we would describe our situation. So the thing that we're looking for when we're asking about what is the relationship, or to describe the relationship, we want to include our independent and dependent variable, what they're doing, and at which interval. Okay, same thing down here. In interval 2, the time increases, the height decreases. Those are the important things when describing our intervals. Okay, that's it for our lesson today. If you have me for class, our assignment is going to be in your book. It's pages 204 to 206, numbers 1 through 12. If you have any questions, please feel free to email me and I'll get back to you as soon as I can.